When we look up at the night sky, we often wonder what lies beyond, in the stars, in other galaxies, in distant corners of the universe. But what if one of the most profound frontiers doesn't lie above us, but below? Thousands of kilometers beneath your feet, far beyond the reach of any human, any drill, any robot, lies a place of staggering heat, unimaginable pressure, and relentless mystery. This is Earth's deep core. We walk on the Earth's surface. We dig, mine, drill. But in truth, we live on a thin shell, like ants walking across an apple, unaware of the vast complexity within. Despite all we've learned about our world, its oceans, its atmosphere, its tectonic plates, when it comes to the inner structure of the planet, we're still working in shadows. We've never seen the core. We've never touched it. And yet, we owe everything to it. It shapes the planet's magnetic field. It drives the movement of continents. It anchors the rhythm of Earth itself. And the more we learn about it, the more it defies explanation. This is the story of how we came to know Earth's hidden heart, and why it may be far stranger than we ever imagined. To understand the core, we need to go layer by layer. Earth is not a solid sphere. It's layered, like an onion, or more accurately, like a planet-sized Russian nesting doll. The crust, which we live on, is just 0.5% of the planet's volume. Beneath that lies the mantle, a thick, mostly solid layer of rock that slowly flows over geological time. Deeper still, at about 2,900 kilometers down, we enter the outer core, a vast, swirling ocean of molten metal, mostly iron and nickel, so hot it moves like water. And then, at around 5,100 kilometers, something extraordinary happens. The pressure becomes so intense that, despite the heat, the metal freezes into a solid. This is the inner core, a ball of solid iron, roughly the size of the moon, spinning silently at the center of our world. It is the densest, hottest, and most inaccessible part of our planet. And we know it exists only because Earth itself told us. We cannot dig to the core. In fact, the deepest humans have ever drilled, the Kola super deep borehole in Russia, reached just 12 kilometers. That's only 0.2% of the way to the center. So how do we know what lies beneath? The answer is elegant. We listen. When an earthquake occurs, it sends shock waves through the planet. These waves, known as seismic waves, travel at different speeds through different materials. They bend, bounce, reflect, and refract depending on what they pass through. By recording these waves at different locations around the world, geophysicists can map the interior of the Earth, just as doctors use ultrasound to see inside the human body. This seismic tomography has revealed Earth's hidden architecture, including the discovery of the liquid outer core, and within that, a solid inner core. But seismic waves don't just reveal structure, they whisper secrets. Secrets about movement, about composition, and about change. It seems impossible. At over 5,000 degrees Celsius, the inner core is hotter than the surface of the sun, and yet it is solid. The reason is pressure. The sheer weight of the Earth compresses the iron atoms so tightly that they cannot move freely, even at those extreme temperatures. It is a solid, but not like anything we know. The iron crystals in the inner core may be aligned in strange patterns, forming textures and structures unlike anything seen on the surface. Some researchers believe it behaves like a single giant crystal, slowly vibrating, bending seismic waves in unusual ways. And it's not static. The core is alive with motion. One of the most mind-bending discoveries in recent decades is that the inner core may rotate independently of the rest of the Earth. Think about that. The center of the planet may spin at a slightly different speed than the crust you're standing on right now. For years, scientists believed the core rotated slightly faster, an effect known as superrotation. But more recent research has revealed a subtler, stranger picture. It seems the inner core may oscillate, speeding up, slowing down, and even temporarily reversing direction. This wobble could be connected to cycles in Earth's magnetic field. It might even subtly influence day length, adding or subtracting fractions of milliseconds from each Earth day. Even more curious is the fact that the inner core is growing. Over millions of years, the molten outer core is slowly cooling. As it does, iron solidifies onto the surface of the inner core, causing it to expand. But here's the twist: it doesn't grow evenly. Studies suggest that the core is growing faster on one side than the other, creating asymmetries that could affect magnetic field strength, seismic behavior, and even mantle dynamics. It's as if Earth's heart is beating unevenly. Why? No one knows for sure, but the implications ripple outward through the entire planet. Perhaps the most critical role the core plays is in generating Earth's magnetic field, the invisible shield that surrounds the planet, deflecting solar radiation, stabilizing climate, and allowing life to flourish. This field is created not by the solid inner core, but by the churning of molten metal in the outer core, a process known as the geodynamo. As this liquid iron moves, influenced by Earth's rotation and heat from below, it generates electric currents. These currents create magnetic fields, which interact and reinforce one another into the vast magnetic bubble that envelopes our world. Without the geodynamo, Earth's atmosphere would slowly be stripped away by the solar wind, as has happened on Mars. The solid inner core acts as a stabilizing agent, helping to maintain the outer core's movement, adding thermal and compositional gradients, and possibly even acting as an anchor for magnetic field reversals. And yet, this system is not permanent. As the core cools over the next few billion years, the outer core will eventually solidify. The geodynamo will shut down. The magnetic field will vanish. Earth will lose its protective shield. The core that gave us life will eventually lead us into silence. For all we know about the core, much more remains unknown. We cannot visit it. We cannot drill to it. We cannot observe it directly. Even our best simulations struggle to recreate the extreme conditions at the center of the planet. Pressures millions of times higher than atmospheric pressure. Temperatures comparable to a star. Unknown chemical compositions. Exotic physics. What kind of iron crystals form there? How do they move? How do they interact with elements like sulfur, silicon, or hydrogen? Some scientists believe light elements are trapped in the core, creating buoyant plumes, contributing to convection and influencing the outer core's flow. Others believe the inner core may be younger than expected, just 500 million years old, forming well after Earth itself. Every seismic wave adds a piece to the puzzle, but the full picture remains just out of reach. The core is not just a ball of metal. It is a driver of planetary evolution, a source of magnetism, a keeper of geological time. It pulses with heat. It spins with momentum. It grows with time. It may even contain clues about the early formation of the Earth and why it was able to sustain life while other planets failed. And yet, it humbles us. Even in the 21st century, with spacecraft exploring interstellar space, the deepest parts of our own world remain veiled in mystery. Perhaps that is fitting, because to understand the Earth's core is not just to understand geology or physics, it is to confront our own limitations, to reckon with the unknowable, to realize that beneath the surface of certainty, wonder still waits. We often look outward for exploration, toward the moon, Mars, the stars. But the Earth itself contains uncharted frontiers, and among them, none are deeper, hotter, or more mysterious than the core. It is the engine that powers our planet, the shield that protects our lives, and the silent sphere that spins alone in the dark. We may never touch it, we may never see it, but every earthquake, every magnetic flicker, every subtle rotation is a whisper from Earth's heart.